Today we will delve into one of the fundamental concepts of C programming, which is parameter passing. First, what is parameter passing in C? And next, the distinction between actual and formal parameters. Moving further, we will understand the two primary methods of parameter passing, which are pass by value and pass by reference. And finally, we will discuss when to use pass by value and pass by reference in programs. Without further ado, let's get started. First, what is parameter passing? Before that, let's understand what is parameters in C. Parameters are variables declared within the parentheses of function declaration or definition. They act as placeholders for values passed to the function when it is called. Parameters enable functions to accept input values from the caller, allowing the function to operate on specific data. So parameters allow functions to use the given data when each time they are called. And these data values can then be used within the functions to perform computations or tasks. Parameters improve reusability of functions by allowing the same function to be used with different input values. So parameters in C pass values to the functions and allow them to work with specific data. So this makes the program more flexible and reusable. Now let's understand what is parameter passing. Parameter passing refers to the process of providing values or references to functions when they are called. In C programming, functions can receive input values through parameters which act as a placeholders for these values. So when a function is called, actual values known as arguments are passed to its parameters. These arguments can be variables, constants, or expressions. And here is the syntax for declaring parameters in C. In C, parameters are declared within the parentheses of a function prototype or definition. Now look at the syntax. Return type, function name. Within the parentheses, we have parameter type and parameter name. Return type, this specifies the data type of the value that the function returns to the calling function. It can be any valid C data type, including int, float, double, char, void, or user-defined data types. Next, function name. This is the name of the function, which should be a valid identifier in C. And it's how you reference the function when you call it from other parts of the program. Parameter type. This specifies the data type of each parameter that the function expects to receive when it is called. The function can have 0 or more parameters. Each parameter is separated by a comma. Next, parameter name. This is the name given to each parameter, which serves as a placeholder for the values passed to the function when it is called. The parameter name must be a valid identifier in C. Now look at the code snippet. Void print numbers int num1, int num2. Void indicates that the function does not return any value to the caller. It is the placeholder for the return type, which indicates that the function does not return anything. Print numbers, it is the name of the function, and this is how you reference the function when you want to call it from the other parts of the program. Int num1, int num2, these are the parameters that the function expects to receive when it is called. In this case, the function expects two parameters, both of type int, and their names are num1 and num2. So the print numbers function takes two integer parameters, num1 and num2, and does not return any value to the caller. Now let's see an example. First, include the necessary header files. Line 3 declares a function prototype for print numbers with two parameters, num1 and num2. It tells the compiler that there will be a function named print numbers, which takes two integer as arguments, but does not provide the implementation of the function. And then we have main function, which is the entry point of the program. Moving ahead, we have two integer variables, x and y, which are declared and initialized with values 10 and 20 respectively. Line 8 calls the print numbers function with the variables x and y as arguments. In line 10, print numbers function is called with integer constants 5 and 15 as arguments. Line 12 calls the print numbers function with expressions x plus 5, y asterisk 2 as arguments. And return 0 statement ends the main function and indicates that the program has executed successfully. Line 16 defines a print numbers function with two integer parameters, num1 and num2. Line 17 prints the value of num1 using the printf function. Line 18 prints the value of num2 using the printf function. Line 19 marks the end of the print numbers function definition. So this code demonstrates how to declare and define a function with parameters and how to call that function with different type of arguments like variables, constants, and expressions from the main function. When executed, the program prints out the values of the arguments passed to the print numbers function. Now let's run this code. And here is the output, first number 10 and second number 20. And this is the output from the first function called print numbers x, y. X has a value of 10 and y has a value of 20. So these values are printed accordingly. And then first number 5 and second number 15. This is the output from the second function called print numbers 5, 15. The function is called with constants 5 and 15 as arguments, so these values are printed directly. First number 15 and second number 40. This is the output from the third function call print numbers x plus 5, y asterisk 2. The expression x plus 5 and y asterisk 2 are evaluated before calling the function. So x plus 5 evaluates to 15 and y multiplied by 2 is evaluated to 40. The resulting values are then passed to the function and they are printed accordingly. So in this program, the values are passed to the print numbers function in each function call, and these values are printed as specified in the function definition. Now let's move on and understand the types of parameters. There are two types of parameters, actual parameters and formal parameters. The parameters passed to the function are called actual parameters, whereas the parameters received by the function are called formal parameters. Now let's discuss them in detail. First, actual parameters in C. Actual parameters are the values that are passed to a function when it is called. They are also known as arguments. These values can be constants, variables, expressions, or even other function calls. When a function is called, the actual parameters are evaluated and their values are copied to the corresponding formal parameters of the called function. Here is the syntax. Function name parameter 1, parameter 2. Here the function name is the name of the function. Parameter 1 and parameter 2 are the actual parameters passed to the function. Look at this example. First we have function declaration and definition, and then we have function call. Add is the function name. 2 and 3 are the actual parameters passed to the function. Result is the variable that stores the return value of the function call. So the function add takes two integer parameters and return their sum. In the call add 2, 3, 2 and 3 are the actual parameters. The values 2 and 3 are assigned to the formal parameters a and b respectively inside the function. The function computes the sum of 2 and 3 and returns 5. The returned value 5 is assigned to the variable result. Now let's understand the formal parameters in C. Formal parameters are the variables declared in the function header that are used to receive the values of the actual parameters passed during function calls. They are also known as function parameters. Formal parameters define the function signature. The function signature consists of function's name and parameters list. The formal parameters specify the type and number of arguments a function can accept. The formal parameters are declared in the function declaration or definition. Now look at the syntax. Return type, function name. Within parentheses we have parameter type and parameter name. Return type is the type of value the function returns. Function name is the name of the function being defined. Parameter type 1 is the type of the first formal parameter. Parameter 1 is the name of the first formal parameter. Parameter type 2 is the type of the second formal parameter. Parameter 2 is the name of the second formal parameter. The function body is the code that defines what function does. Now look at the example. First we have function declaration, that is int add. Inside parenthesis we have int a, int b. Int is the return type. Add is the function name. Int a is the type and name of the first formal parameter. Int b is the type and name of the second formal parameter. And then we have function definition. And here int is the return type of the function, indicating it returns an integer. Add is the name of the function. Int a, int b are parameter list, specifying two integer parameters named a and b. And the function body is enclosed by curly brackets containing the code that defines what the function does. So in this case we have return a plus b. This statement returns the sum of a and b. The return keyword is used to exit the function and provide the result to the caller. Now let's see an example that demonstrates the use of functions with formal and actual parameters to calculate the sum of two integers. First, include the necessary header files, and next we have function declaration. So line 3 declares a function named sum that takes two integer parameters a and b and return an integer. And next, the main function. The main function begins by defining two integer variables num1 and num2, initialized to 5 and 3 respectively. The sum function is called with num1 and num2 as actual parameters. The result of this function call is stored in the result variable. The printf is used to display the result. And then we have function definition, and this block defines what the sum function does. It takes two integers a and b, adds them and returns the result. So in this program the actual parameters are the values you pass to the function when you call it. So in the main function num1 and num2 are the actual parameters. Formal parameters are the parameters defined by function that will receive the actual parameters value. In the sum function a and b are formal parameters. So when sum function is called, num1 is copied to a and num2 is copied to b. The function then computes a plus b and returns the result. Now let's run this program. And in output you can confirm that the sum function correctly adds two integers and returns the expected result. Now let's discuss parameter passing modes in C. When discussing function parameters, the modes in, out, and in-out describes how data is passed between the caller and the callee. Before discussing the modes, let's understand the definition and roles of caller and callee. The caller is the function that makes a call to another function. The caller initiates the function call and typically provides any necessary arguments, which are actual parameters. The callee is the function that is being called by another function. The callee executes its code in response to the call and often processes the provided arguments, which are formal parameters. Now let's discuss the parameter passing modes. First, in mode. In mode means the parameter is used to pass information from caller to callee. The callee can read the value, but it cannot modify the caller's variable. So here the parameters are passed by value, meaning the function gets a copy of the variable's value. The out mode means the parameter is used to return information from the callee to the caller. The callee writes a value into the caller's variable. Typically, it is achieved using pointers. So the function receives the pointer to the variable and modifies the variable's value directly. Next, in-out mode. So here the parameter is used both to pass information to the callee and to return information to the caller. The callee can read and modify the caller's variable, and it is achieved using pointers, as the function can read and modify the value through pointer. Now let's see an example. And this code incorporates in-out and in-out parameter modes, clearly showing the role of caller and callee along with actual and formal parameters. First, include the necessary header files, and then we have a function declaration with in-out and in-out parameters. Line 3 declares a calculate function. This function takes 4 parameters, 2 integers a and b, next a pointer to an integer sum, and another pointer to an integer product. A and b are in parameters, sum is an output parameter, product is an in-out parameter. And next we have main function, which is the entry point of the program. Int num1 equals 5 is the actual parameter for in mode. Here we declared an integer variable num1 and initialized to 5. Num1 is an actual parameter that will be passed to calculate function. Int num2 equals 3. This is actual parameter for in mode. Here we declared another integer variable num2 and initialized to 3. Num2 is also an actual parameter for the calculate function. Int sum underscore result. This line declares an integer variable sum underscore result, which will hold the result of the summation calculated by the calculate function. And this is for the out parameter. Int product underscore result equals 1. This line declares an integer variable product underscore result and initialized to 1. This variable is used to store the product, and this is for in-out parameter. And next we have function call with actual parameters. Line 11 calls the calculate function with 4 arguments. Num1 and num2 are passed by value. Ampersand sum underscore result and ampersand product underscore result are passed by reference. So num1 and num2 are in parameters. They are copied to a and b in calculate. Ampersand sum underscore result is out parameter. Ampersand product underscore result is in-out parameter. Ampersand sum underscore result and product underscore result are passed by reference, which means addresses of sum underscore result and product underscore result are passed to calculate function. Inside the calculate function, sum and product are pointers that refer to the actual variables sum underscore result and product underscore result. And next we have printf statement to print the sum of num1 and num2, which was calculated in calculate function and stored in sum underscore result. Next, printf statement is used to print the product of num1 and num2, which was calculated and updated in calculate function and stored in product underscore result. The return 0 from the main function indicates the program executed successfully. Line 16 marks the end of the main function. And then we have callee section. Here we have a function definition with formal parameters. Line 19 starts with the definition of calculate function. It takes 4 parameters. Int a and int b are in parameters. Int asterisk sum is an out parameter. Int asterisk product is an in-out parameter. Asterisk sum equals a plus b. This line calculates the sum of a and b and stores the result in the memory location pointed to by sum. Since sum points to sum underscore result, so the value of sum underscore result is updated with the sum of a and b. Line 26 multiplies the current value pointed to by product by the product of a and b. And note that product is initially 1. The result is then stored back to the memory location pointed to by product. Since product points to product underscore result, so the value of product underscore result is updated with the product of its initial value and the product of a and b. Line 27 marks the end of the calculate function. Now let's run this code. The sum of 5 and 3 is 8. This output is generated by the first printf statement. It displays the value of num1 and num2 and calculates the sum stored in the sum underscore result. The calculate function added 5 and 3 to get 8, which was stored in sum underscore result. The product of 5 and 3 is 15. This output is generated by the second printf statement. It displays the value of num1 and num2, and the calculated product is stored in product underscore result. The function calculate multiplied 5 and 3 to get 15, and this product was multiplied by the initial value of product underscore result, which is 1, resulting in 15, and it was stored in product underscore result. Now let's discuss the parameter passing methods. Functions in C can be invoked in two primary ways, which are generally differentiated by how the values are passed to them as parameters. The two primary methods are pass by value and pass by reference. Now let's discuss them in detail. First, pass by value. When a function is called by value, a copy of actual parameter's value is passed to the function. The function operates on this copy, and any changes made to the parameter within the function do not affect the original argument. This method is also called as call by value. Now look at the syntax. First, we have function declaration. In function declaration, data type parameter underscore name specifies that the function name takes a single argument of type data type. So when you declare a function like this, you are telling the compiler there exists a function like the signature, but you are not providing its implementation yet. Here the function name takes a parameter of type data type and returns void. However, data type should be replaced with actual data type such as int, float, char, depending on what your function needs. And then we have function definition. It provides the actual implementation of function name. Inside the function body, you write the code that performs the desired action based on the value passed to parameter underscore name. And then we have function call. Here function name is called with an argument. In pass by value, the value of argument is copied and passed to the function name. This means the changes made to the parameter underscore name inside the function will not affect the original value of argument outside the function. It essentially creates a local copy of the value. Now let's see an example. In this example, the swap function demonstrates pass by value by swapping its local parameters a and b, which does not affect the original variables x and y in the main function. First, include the necessary header files, and then we define a function named swap, which takes two integer parameters a and b. The function is defined to return void, which means it does not return any value. Inside the function, the temporary variable temp is used to swap the values of a and b. Temp equals a saves the value of a into temp. A equals b assigns the value of b to a. B equals temp assigns the value of temp, which is the original value of a, to b. Since the function uses pass by value, the changes to a and b are local to swap function and do not affect the original arguments passed from the main function. And then we have main function, which is the entry point of the program. Here two integer variables x and y are declared and initialized to 10 and 20 respectively. The printf function is used to print the values of x and y before the swap function is called. Swap x, y calls the swap function, which pass the values of x and y to the function. Since swap function uses pass by value, so the values of x and y are copied to the parameters a and b within the function. Any changes made to a and b inside the swap function do not affect x and y in the main function. After the swap function call, another printf statement prints the value of x and y. Since x and y were passed by value, not by reference, so their values remain unchanged in main function. Finally, return 0. This statement ends the main function and returns 0 to the operating system, indicating that the program has executed successfully. Now let's run this code. In the output, you can see the values of x and y remain unchanged before and after the call to swap. Now let's move on and understand pass by reference. C does not support pass by reference directly. However, it can be done by passing pointers to the function. So when a pointer is passed, the function can modify the value of the variable that the pointer reference to. So in pass by reference method, the memory addresses of actual parameter is passed to the formal parameters. The formal parameters must be pointer variables to hold the addresses of actual parameters. Changes made to the formal parameters will directly affect the actual parameters because the formal parameters point to the memory location of actual parameters. Now look at the syntax. First, function declaration. The line void function name, data type, asterisk parameter name declares a function named function name. This function takes the parameter of a type, data type asterisk, which indicates a pointer to a variable of type data type. And this declaration informs the compiler about the function's name, return type, void in this case, and the type of parameter it expects. Next we have function definition. The block of code between curly bracket is the definition of a function named function name. It specifies what the function does when called. Here the function body is empty. We have to write the actual code inside the function body to perform some operations. And then we have main function, which is the entry point of the program. Inside main function, there is a function call. There is function name inside the bracket ampersand variable. Here the function name is called with an argument ampersand variable. Ampersand variable means address of the variable named variable. The AND operator gets the memory address of a variable. So here we declared and defined a function named function underscore name. The function expects a pointer to a variable of type data type. In main, the function is called with the address of a variable which matches the expected parameter type. Now let's see an example. First, include the necessary header files, and then we have a function to swap two integers using pass by reference. Here we declared a function named swap. The function takes two parameters a and b which are pointers to integers. Inside the function, the values of the memory addresses pointed to by a and b will be swapped. Int temp equals asterisk a. This line declares an integer variable temp and assigns a value pointed to by a. Asterisk a equals asterisk b. This line assigns the value pointed to by b to the memory location pointed to by a, and this will swap the values of x and y. Asterisk b equals temp. This line assigns the value stored in temp to the memory location pointed to by b, and this completes the swap operation. Line 7 marks the end of the swap function definition. And then main function, which is the entry point of the program, int x equals 10, y equals 20. This line declares two integer variables x and y and initializes them with the values 10 and 20 respectively. Line 10 prints the value of x and y before the swap operation using the printf function. The %d format specifier is used to print integer values, and x and y are arguments. Next we call the swap function with address of variables x and y. Swap ampersand x comma ampersand y. This line calls the swap function and passes the address of the variables x and y as arguments. The AND operator is used to obtain the address of the variables x and y. And this printf statement prints the value of x and y after swap operation. Now the values of x and y have been swapped by swap function. %d format specifier is used to print integer values, and x and y are arguments. And finally the return statement, which indicates the successful program execution. Now let's run this code. Now look at the output. Before swapping, x equals 10 and y equals 20. This line is printed by the printf function before the swap function is called. It shows the initial value of the variables x and y, which are 10 and 20 respectively. After swapping, x equals 20 and y equals 10. This line is printed by the printf function after the swap function is called. It shows the value of variables x and y after they have been swapped by swap function. The value of x is now 20 and the value of y is now 10. So initially x is 10 and y is 20. After calling the swap function with address of x and y, the values of x and y are swapped. After the swap, x becomes 20 and y becomes 10. Now let's see a comparison between pass by value and pass by reference in terms of syntax, function call, function definition, modification capability, memory usage, and function signature. Talking about the syntax, in pass by value, the parameter in the function declaration uses the regular variable type int x, which indicates that the copy of the value will be passed. In pass by reference, the parameter in the function declaration uses a pointer variable type. There is int asterisk ptr, which indicates that the function expects the address of the variable. Now function call. In pass by value, the function is called with the variable itself. In pass by reference, the function is called with address of the variable, which is denoted by AND operator. Function definition. In pass by value, the function definition receives the value directly. Whereas in pass by reference, the function definition receives a pointer to the variable, which allows the direct access to variable's memory address. Talking about the modification capability, in pass by value, changes made to the parameter inside the function do not affect the original variable, because the function operates on copy of the value. In pass by reference, changes made to the parameter inside the function directly affect the original variable, because the function operates on the variable's memory address. When dealing with memory usage, the pass by value requires additional memory for storing a copy of the variable. In pass by reference, memory is efficient because it operates directly on the variable's memory address without creating a copy. Function signature. In pass by value, the function signature indicates the use of regular variable type in parameters. In pass by reference, the function signature indicates the use of pointer variable type in parameters, which allows access to memory addresses. Now let's discuss the advantages and disadvantages of both methods. Talking about the advantages, the pass by value have a predictable behavior because the changes made inside the function do not affect the original data, so that it is more predictable and safer code. And it supports encapsulation because the function works with copy of the data, thereby it maintains the integrity of original data. Pass by value is simplicity in nature because this approach is straightforward and easier to understand, since each function has its own copy of the data. Talking about the disadvantage of pass-by value, first we have copying overhead because copying large data structure can be time consuming and use lot of memory. Next, inability to modify original data. That is, changes do not affect the original variable. Now coming to pass-by reference, the first advantage is efficiency because it avoids the overhead of copying large data structures so that it improves performance and conserve memory. And next advantage is ability to modify original data. That is, the functions can change the original data. And then memory efficiency. Pass-by reference operates on pointers rather than copying large data. So the memory usage is less. Now talking about the disadvantage of pass-by reference, potential for unintended modifications. That is, functions can accidentally change the original data, which will lead to bugs if it is not carefully managed. And then complexity, because pointers can be difficult to work with and error prone. And next, encapsulation breakage. The direct access to the original data can break encapsulation, which makes it harder to manage and debug code. Now let's move on and understand when to use pass-by value and pass-by reference in C. Pass-by value is ideal for immutable data. That is, data cannot be changed after it has been created. So it ensures the data remains consistent and prevents side effects that alter the data. So you can use pass-by value when you want to avoid side effects and ensure data integrity. Whereas in pass-by reference, it is not applicable since the data does not need to be modified. Pass-by value works well with small and simple data types, whereas pass-by reference works well with large data structures. Pass-by value can be used when you don't need to modify the actual parameter, whereas pass-by reference is used when you need to modify the original data. Pass-by value is used when you want to avoid side effects and ensure data integrity. Pass-by reference is used when you want to avoid the overhead of copying large data. And that's all for this session. Thank you so much.